Hey guys, Sebastian from Madrigal here. Welcome to part 12 of the video series where we create a Vulkan backend for the Basis game engine. If you haven't watched the previous parts, be sure to do that first to get a better idea of what we're doing here. So, this may or may not be the final part in this video series. We are very close to actually getting something on screen. And we will continue this part right where we left off the previous one. So we were filling in the render context class. We had just gotten the draw calls done, so basically these guys. And we will continue with the constant buffer. So again, looking at what I have done with the previous parts. The previous, not previous parts, but the previous rendering backends that I have done. I will put in some things here that I have considered to be good practice there. Apparently, some part of my code calls bind constant buffer with null, and if that happens, let's just return. So we do what we do with almost all types that we pass in. We statically cast them to the correct type. So buffer. This should be just buffer like this. Okay, so binding a constant buffer, that's pretty simple. That would be VEZ command bind buffer. And VK buffer, so that would be buffer buffer VK get buffer page. And we have offset and we have range. So. Right, let's do uint 32 offset is 0, and the array element is also 0. So let's put that element. So here we can use offset, and range can be set. We can use this magical VK whole range macro, which we used previously when we did the buffer class. Then we have the set. The set is always 0 here. I don't use any other descriptor set except 0. And here we actually get into some of the details of how we actually bind things to shaders. So there's this thing called the shader binding slot. And shader binding slot has HLSL style registers and it has GLSL style bindings. So you have a register slot and you have a register type. And type can be T, U, S, or B. This is just how HLSL binds things. And it can also have a binding slot index. And that is indeed what we want in this case. So this would be slot.binding slot index. And then array element is array element. What is the problem here? Oh, it's not called, it's called size, right? Yes. Whole size for the range. And let's make sure that builds before continuing. Okay, that looks good. Then we have right, so then we have this very weird thing here. This is an overload of the bind constant buffer function. We already did one, we have another one. And here we actually, we are very deeply in D3D11 land here. So let's copy these things, and the offset is going to be first constant times 16. And this is essentially a D3D11.1 feature where you can actually bind parts of a constant buffer and map that onto a constant buffer in the shaders. It's kind of messy. It's actually not used at this very moment in the engine because because I don't need it currently, but I occasionally use this feature of D3D 11.1, and yeah, you don't actually measure the constants in like bytes. You measure it in constants that are like 256 byte long chunks of data, if I remember correctly, something like this. We just do basically the same thing here as we do in Metal, where you just use this times 16 and you get the offset into as a byte offset. In Metal and in Vulkan, you can just map any kind of buffer with just a normal byte offset, as far as I know. So you don't need to do this whole weird thing. Again, set is always 0, and binding is always slot.binding slot index, and array element is array element. And constant count, where do we put that? Yeah, we might not actually need that since we just mapped the whole size here. I think this will be fine for now. Then we have structured buffer, and this should be actually the same thing as just a constant buffer in Vulkan. So we'll just map it like this. Yes, shader stages is right there. Yeah. We actually don't use the shader stages here because that's not really how binding works in GLSL. But it doesn't matter. Texture sampler. So again, if we don't have a sampler, we just early out. And we do the same thing as we do with all of this, and that we do a texture sampler VK. Texture sampler, which is probably has been the easiest part of this whole thing. And we do VEZ command bind sampler. Yeah. And it's sampler VK, get VK sampler. Again, set is always 0. This is always slot.binding slot index. Array element is 0. All right, so then we have the textures. And the textures are essentially the same thing. We just do this, and we do texture VK, texture, and we can simply take this sampler part away. And then we do texture VK. No, oh, one second actually. I think if we look at, I remember seeing something about this. So we need to bind an image view, right? That's what we actually want. And textures can be treated as just pure textures or as like a texture / sampler combined value. That's not really anything that I use in Basis. So what we're going to do here is just we'll set up a sampler handle. It's not supposed to have that there. Set up a sampler handle and assign it to a null handle. And and here we can do get VK image view. Texture array index is, yeah, that's 0 in this case. And what is that? What is the next one? Sampler, right? So this is where we pass the sampler, which is always going to be VK null handle, but I feel like this documents it pretty well. That okay, we're actually passing a handler here, or a sampler, and if we pass a null sampler, then it's going to treat it as not a combined texture sampler, but just a normal texture or image. Array element is also 0. And as for the, in some sense, final method here, we just have the exact same thing, but we have a format here, and here we can quite easily we can just put the format there to get the VK image view with the wanted format, and that should be exactly what we want. So we can just quickly have a look at the docs. And here you can see this combined image sampler. So yes, this is what I was talking about. I remember reading this earlier. So when you use command bind image view, allows an application to specify sampler alongside the image view. When sampler is VK null handle, the binding represents a sampled image or texture 2D in GLSL. And that's essentially what we have. HLSL doesn't have combined image samplers. It only has images or textures, really. So that's what we want to have. But I put them here as a separate line to make it very clear that this sampler is going to be null. All right. So that should really be it. This one I will have to do at some point to generate MIPS. It is used currently at runtime. I think the only place that uses it is the eye adaptation effect, which might actually behave a little strange without that, but it should still work. I'm gonna have to look into that. We don't need to implement these unbinds, and we don't need this timer frame, timestamp, and these their debug functionality essentially. So let's see what we have. Let's try to run this now, and with some luck we should be able to see something. All right, so we have a crash, and what is the crash? This was null pointer. Okay. Oh, okay. So we have this thing, which I mentioned earlier, that you can actually sort of bind null, and you're expected to handle that in basis. So let's do like if not vertex buffers, or if not the first element of vertex buffers, then let's just early out. Okay, let's try that again. I expect us to have to do this a few times. Okay, so first error. Let's take a deep breath and copy this, and some earlier tests. So deep breath, and let's see what the actual error is. Okay, create graphics pipelines is throwing an error. Subpath 0 has color attachment count of 2, which doesn't match the p-color blend state attachment of 1. Okay. Okay. So probably what we need to do here is when we bind, let's look at pipeline state VK. Before we actually bind anything, we probably have to set color blend state. So VK render path 0, subpath 0 has color attachment of 2, which doesn't match the color blend state attachment count of 1. Okay, so even though we don't necessarily use all of those, we still need to the count needs to match. So render target m color attachment count, right? Whoop. Right. Attachment count equals render target color attachment count. I think that should probably fix it, at least for the time being. Hey. Okay, we have things on the screen. We have Vulkan, and we have 41 frames in debug mode, and we have somewhat working ImGUI windows. Look at this. Look at this first Vulkan graphics on the screen. And if we try to exit this, it will again, once again, it will be unhappy with us since we are using stuff that's still in use by command buffer. Right, so I think I know what's happening here, and it is like, this is what it's supposed to look like, right? Yes, this is what it's supposed to look like, and we got essentially the shapes were correct, but the blending is not correct. The colors aren't correct. So this has to do with how we handle the buffers. And if you remember, buffer vk, we have this thing here where we create like frame buffers, we create new pages, and map them so that each time you actually call get buffer page, if there is new data, then we are writing it using this. And I actually recognize this problem because I've seen it with the metal one as well, which also uses this system. So the problem can be found most likely in NanoVG Graphics API. This is the code that's responsible for rendering the UI. And if we look for Apple, right? So here we have a sort of a hack that I put in for the metal backend, and we'll actually need it for the Vulkan one, as long as we handle our buffers here. So what actually happens here is that we have a buffer, PS constants, we map to it, but if we don't do this, then the stuff that we have written to, like we have mem-copied new data into the buffer here. But if we don't do this bind here, before we actually go and draw things, then this memcopy won't have any effect. Because if you remember, like we do bind constant buffer, and then we go into here, and then we go into get buffer page, and here we have the buffer page, which is calling the actual write using map, and this is uploading the new data to the GPU. And on D3D11 this will work because you can just map a buffer, and if it is bound, then the newly mapped data will be visible on the GPU. That's not really the case on these ones. So I bet if we just remove this check for Apple platform here, at least for the time being, we should actually see the correct. Hey, look at this. Look at this. Pretty cool. Okay, and the UI works. Not that it should really matter what rendering backend we use. Okay, do I dare press enter here? Are we gonna see something interesting, or is nothing? Keep in mind that we're running now on Vulkan, which is going to be slower, and we're running a debug build, which is even slower, and we're running with validation on. So this is like in the best scenarios, this is going to run at like 1 frame per second, probably. I mean, we had like 40 frames in the menu, which did almost nothing. So this is like the slowest build you can imagine. But we'll run it with release and validations off as soon as we know that we have something. Okay. Okay, we have a warning. Fragment shader writes to output location 1 with no matching attachment. Yeah, this is actually kind of expected. Let's just ignore that. And all right. I'm just gonna copy this guy. So let's copy it and let's put it in its own file. And we'll have a look at it in a second. But let's actually ignore that and let's see if we have anything. Do we have anything visible? Frame per second 0, that's not good. That's not good at all. 2 frames per second, okay. Alright. Alright, so we don't really get anything. Alright, okay. Let's try another thing. Actually, let's just for shits and giggles. Shits and giggles, and as well as a little bit more performance. Still running in debug. I'm gonna switch to release in a bit. Let's try to take the validations away. And you can see we already gain like 15 frames even in debug mode per second when we disable the validation. They eat quite a lot of CPU. This is still gonna be super slow because we're running in debug mode. But we might actually get to see something, I'm hoping. Hoping we would. And I ran it through this top menu now, which should load into the level without the intro sequence. Oh, hey, we had something. What do we have? Oh, hey, okay. So, yeah, this actually, yeah. Okay, this is because of the mipmap generation, probably. I would assume. Like we can we can actually play the game. It's very dark. It's very dark. Oh no, the trees are on fire. The trees are burning. Oh no. Yeah, the eye adaptation is going a little crazy because we don't do the mipmap generation properly. And when you have something that's this bright, actually the trees are not on fire. The trees are literally the sun. Okay, but that's interesting. But think about it. We are actually rendering with Vulkan. We're rendering this thing with Vulkan. So let's have a look at the error we saw earlier. And while we do that, let's rebuild in release mode, and we can re-enable the validation layers. We want to get rid of all the errors after all. So that one warning can stay, but the errors we want to get rid of. And as usual, I'm gonna restart Visual Studio when I switch between debug and release, just to make sure that Visual Studio doesn't trip up on that change, because especially this 2019 version of Visual Studio is kind of prone to get weird behavior when you change the configuration on a really large project. Okay, so what do we have? Where did I put that error that we got? So these tend to be really long, so let's like split it into a few lines. So it's an error. VK update descriptor sets. Failed write update for validation. VK descriptor set with error. Write update VK descriptor set. Allocated with VK descriptor set layout. Binding 5. Fail with error message. Attempted write update to image descriptor failed due to image view. Has both stencil and depth aspects set. Okay. Okay. Yeah. Obviously, we don't call this guy. We haven't called any update descriptor sets ourselves. This is something that happens inside VEZ most likely. But the problem is this: that we've given it an image view with both stencil and depth aspects. So if we go to... Oh, did it actually finish already? Apparently we had like the rest of the program already. Look at this, like now we're getting 120 frames in the menu with the release build. Yeah, we're still gonna get this. It's in use by command buffer. We're getting some weird artifacts there as well. I need to fix that, but not today. Right, if we go to the texture VK, and do we have any aspect things here? No aspect. It has both stencil and depth aspects. I wonder if the problem is that we don't set any aspect at all. Nope, not that one, but this one. Like this has the aspect. We don't actually set any aspect, and I could almost certainly. I can at least imagine that VEC is going to set some aspects based on the usage. So this usage flag here. Let's go into... Can I go into VEC? Is this going to work? Might actually not work. Yeah, no. I have this VEC project is generated on another machine. But what we can do is we can go here and we can just find in files. So in here, and we can do like maybe .h and .cpp, and we can do the what are we looking for? Aspect. Vulkan, come on. And Vulkan core is probably what I want. Aspect. No aspect. What? Come on. Are you telling me there's no aspect in this whole thingy? Aspect. Yes, aspect. Okay. So depth and stencil bit. So let's look for that thing inside VEZ. Let's see what we come up with. All right, so we have here is the image aspect flags. Oh, hey, okay, yeah. So this is kind of a bug in VEZ, isn't it? Because it probably calls this guy and sets some aspect on the image based on the format. And I would assume that we're actually using like one of, if we go to the, what was it? Was it the device maybe? Device VK. And in here, let's go here. See, we're in release mode now, so nope. Yeah, let's comment that out for a bit. Use Vulkan. Okay. So what do we have here? We have buck buffer sRGB. Okay, that's not actually what we wanted. That's not what I imagined. Was it swap chain? swap chain VK. Yeah, depth buffer format is set here. Let's see what do we have? Yes. Unknown. That's not true. This is just the. That can't be true. No, it's not true. It is not true. So it's this. This is the depth buffer format that we used, or depth buffer format. Sorry. And if we look at this, and then we go into the type conversions VK, and we look for that guy, we get D32 sfloat S8. And when we find that, we find it here, and VEC is setting both the aspect and depth stencil bit. Why? Why? Is this something that is like called if we don't set it ourselves? That looks promising. If we don't have an aspect, then we get it. Otherwise, we use the aspect. Okay, that looks good. Let's hope it's actually that. So if, what do we need to do here? Like if we don't really do any stencil buffering currently, right? So, or we can at least, sort of say that it's more likely that a buffer, a depth stencil buffer, is actually a depth buffer than a stencil buffer. So if we go to texture VK, and what do? We do texture description flags, GFX API, texture flags, depth stencil. Right? So if this texture is one that has been created with this flag, depth stencil flag, then we take this guy and we set aspect to VK image aspect depth. Right. And that should make VEC not call that function which sets both of the aspects. Right? Right? Let's just go into the game, see what happens. We're gonna get the warning? Yes. Getting the warning, ignoring that. Hey! Look at that. Beautiful. Beautiful stuff. Beautiful stuff. Doesn't look quite right, and that's probably because of the generate MIPS function not being there. So the and there's something funky going on with this, some like moire pattern almost on these rocks. So there's still something to figure out here. So yeah, the performance is kind of horrible, but everything looks quite nice. Even the water looks correct now. We didn't have any water previously when we had like trees on fire and everything was chaos. And yeah, it reflects the car and everything. Hey. Yeah, that weird wobble with the terrain that you saw, by the way, is that is not doesn't have to do anything with Vulkan. That's just my streaming position getting slightly delayed, updated with the delay when I switch to free camera. Yeah, this is kind of horrible performance, obviously. Let's shut this down and let's see what happens if we go into the back end and we turn off the validation, because we only have the one warning now. We don't have any validation errors actually. So do we get better performance now? A little bit better performance. Not good. I mean, this should be This should be probably locked 60 frames on this machine, even though this is not the most powerful one, but yeah, well, it's it's not very good. It's not very good, as it. Um, let's try to play this a little bit. I wonder about the moire pattern. That looks kind of funky. Yeah, like you can see here these kinds of things. Like, what is that about? It's probably some. Is that like shadow acne? Actually, yeah, yeah. It goes away with the if we turn off the shadow. So it's a shadow acne kind of deal. Okay, so there's some bias thing that we probably just we missed something, or we did something incorrect in the pipeline state, right? Yeah, this looks really really bad actually. Like you have these crazy moire patterns here. Let's try to fix that. Let's see what we have now. It's bound to be somewhere in the pipeline state. So pipeline state VK. Let's go have a look here somewhere. Where do we actually put those? Depth bias enable. Depth clamp enable. We actually. Oh, we don't set those. Well, that would be why. Huh. How stupid of us. So, desk, rasterizer, depth bias. Oh, that's an integer, and this is a float, is it? Let's cast it to a float then. Then we have depth bias clamp. Is desk dot rasterizer dot depth bias clamp, and that is a float. And then depth bias slope factor. Whoa. Sloped scaled depth bias. Yeah. Yeah, I bet this is gonna make things better. It looked like shadow acne, so good. Yeah, now it looks better. Like we can toggle shadows on and off, and it pretty much looks the same. There's no weird moire patterns on the things that aren't in shadow anymore. Okay, good. Actually, what we can do is we can toggle some of these things on and off. Where should we start? Well, shadows, obviously, they work. We don't have the HBAO, but we do have SSAO. Clearly does work. And yeah, the anti-aliasing works very nicely. You can see it on this these objects on the roof of the car, for example. Very cool. Okay. So you can toggle the sky, you can toggle the distant objects. That works. Excellent. Light maps, light probes. This is like dynamic objects. Hey, very cool. Very cool indeed. Water, obviously. And decorations. Decorations off might give us a little bit more performance, but it looks really empty. So, what about the debug drawing? That seems to work quite well. Excellent. Load bounds. Nav meshes. Oh, we can't actually draw nav meshes because that's on the server, and we need to run server on the render thread, which you can do if you want to, but yeah. ABBs, like obviously, here is there's something weird with the. Yeah, here we have some weird darkening. Yeah, this kind of stuff happens because we haven't implemented the the generate MIPS function, which is quite important for the eye adaptation algorithm to work properly. And if you don't know what I mean, you can do something like, you can go into like a pretty dark corner like this, and you can actually see the colors kind of change. There's some banding there going on. So it's almost like your actual eyes kind of reacting to the darkness. Dark, and then you look at something bright, and it's supposed to kind of mimic the human eye. But yeah, this is not bad at all. Fog, particle systems, turn fog back on. Yeah. Terrain, obviously, can turn off. You can see that we're actually not really GPU bound, it would seem. We don't really get... I'll get a few more FPS now, but I bet we're like really heavily CPU bound, which means that I get to go in and look at what VEC is doing and actually try to optimize that a bit, which is something that I definitely want to do. And just that one thing that I mentioned that I would like to do, simplifying the way we bind the pipelines, is probably going to give me quite a lot more performance than what we currently see here. Because GFX API tries to be like slightly modern in the sense that it has render passes, it has PSOs, and VEC is kind of like doesn't expect the graphics API to have those things. So it can't really use them, and that's one place that I could really kind of try to improve VEC a little bit. Yeah, this downed airplane here is like a very good place for looking at if the light maps work. What about the object paint? Seems to work as well. Okay, so everything is working. Everything is working. How wonderful. This kind of turned out better than I had actually expected. We only spent about half a video investigating problems, not like 3 videos or anything. And obviously this performance is really terrible. Like I kind of mentioned in the beginning of this series, like I kind of fully expect it to be very bad. Let's see if we can blow up someone here. This is super difficult to aim, this railgun. Now we're just aiming at the ground. Boom. Haha. Alright, come on. Let's... Oh. No. I'm gonna shoot you. The combat is really bare bones still. Anyway, I kind of consider this a mission complete, mission accomplished as far as getting the game to run on Vulkan is concerned, because we're playing it on Vulkan now, and it's not completely broken. In fact, it looks, apart from some minor things like the eye adaptation not quite looking correct, and probably, you know, this thing still completely breaking. We don't have the validation layers on, so actually it shut off pretty nicely. But I mean, if we run it with D3D11, just load into the level here, and we can go into roughly the same place we were landed by the garage. Yeah, this machine is not the best, so we were only running about 30-40 frames per second here. So there's clearly some optimization to be done still on the engine overall. I would like this particular machine to be able to run this level at 60, at a locked 60. But now that we have it running on Vulkan, we can sort of take a different approach to optimizing. And we have two different APIs to sort of work with and optimize for. And yeah, I think there's something with the colors or something is slightly off with the Vulkan version. This looks kind of more correct in my opinion still. But very small things, and considering I only used about a week recording these videos, it's a pretty good outcome. Of course, I spent a little while playing around with VEC before I started this. And if you would like to mess around with VEC yourself, then I highly suggest you look into at least some of the fixes and pull requests that have been published after the official one stopped being developed. And you're fully welcome to use my fork if you would like, but I have a few changes in there that are designed specifically for this engine, so have a look at the log if you do. Anyway, with this and at this point, I thank you very much for your time if you followed me on this crazy adventure, and stay tuned for other kinds of videos. If I get this running on the Steam Deck, I will post a follow-up video for sure, and let you guys know how actually running Vulkan on that device turned out. But I don't know yet if that is going to happen, but keep an eye on the channel for more stuff regardless. Anyway, have a good one, and I will see you in the next video. Bye.